Well, after a great 8 seasons, well, maybe the first one wasn't that good. No, no spoilers. At least they killed it in the end. I'm sorry, Shai. It's finally here. AngularIP, the third renderer to his name, is now sitting on the Iron Throne. I hope most of you guys watched Game of Thrones, and if not, do yourself a big favor, and this weekend, just catch up. How many of you already upgraded your project to Angular 8? A few. Uri Shaker. How many of you already using AngularIP in production? Ooh. No. Well, sometimes I hope I'm not the only super early adapter in the world. Glad to see some more brave developers here. No. Eliran, I'm a front-end developer specialized in B2C application. I'm a consultant and trainer in 500 Tech. I'm also taking part in two things which I'm really proud of. The first one is AngularAL meetup, which is a top 10 member in the biggest Angular meetups in the world, which is crazy considering the fact that Israel is a really small country. The second one is this conference. I have to admit that last year was my first time here on that stage as a speaker, and this year I've joined the organizing team as the one who's in charge of the content. This is a great opportunity for me to stop for a second and say thank you for being such an amazing community, making this meetup and conference so awesome. Round of applause. Now, did I shout? Let's talk about Ivy. So after a long wait, Ivy is now available in version 8 as an opt-in version. It's not 100% ready, but for most use cases, you can start using it. And I thought that can be a great opportunity for me to go to a deep dive inside the new renderer of Angular. Flashback, Ivy is actually the third renderer shipped by the core team. It started with version 2. We had the template compiler. In version 4, we had the view engine. And Ivy is the third one. This is actually a rewrite and replacement for the view engine, but the most important thing here, it's happening under the hood. And for most use cases, it should be almost transparent for you as developers, since it's supposed to be 100% backward compatible. So why Ivy? First and foremost, because of that device we are all holding, Revi. It sounds insane, but 60% of all US online traffic comes from smartphones and tablets. By the end of this year, 80% of internet usage is supposed to come from mobile devices. So one of our biggest challenges as front-end developers is to have the best mobile user experience. And even though sometimes it's out because internet connection on mobile is pretty slow, or could be slow at least. What we can do to make it better, we can and should use CDNs to serve our app from the closest cloud. We should use lazy load to separate our app into smaller chunks. We also can use PWA to cache assets, but the biggest opportunity we have as developers is reducing the bundle size. We want to ship the minimum of bytes to render our app. So I took Eliassy.dev as a use case. This is a website I'm using to share talks and sessions I have. And it looks like a simple website, but it uses a lot of core features from Angular. Like the PWA, as you can see, it supports full offline. It's also using some material modules and the animation module. Any guess what's the bundle size of this app? 1 kilobyte, no way. Another one, maybe? So before Ivy, my main bundle weight was a bit more than 500 kilobytes. Now, let's opt in Ivy and compare. So in order to opt in Ivy, I just need to edit tsconfig app.json file and add a section Angular compiler option and set the enable Ivy flag to true. If you are generating a new project in Angular, just use the ---- enable Ivy in your ng-new script. Now, as you can see, the bundle shrunk in 77 kilobytes without doing nothing, which is 50% of the bundle size. The meaning is our website is now 50% more faster. Some of you might be disappointed by the fact that it's only 50% of the bundle size, and the reason for that is, even though this is a small project, it's relying on a lot of core features. And as for now, Ivy is mainly cutting the generated code and not the framework itself. But yet, this is quite impressive. So what's behind it? How does it work? And to understand that, we need to go for a deep dive inside the internals of the compiler. So let's take this simple code, for example. And now, is anyone in the crowd had the chance to run the Angular compiler without ngserve or ngbuild? Only few. So what's, sorry. Yeah, so if we tried it, I'm going to run the compiler manually by using the ngc command. I'm actually already did it, so we won't wait for builds. This is the command I've used. So wait a second. Let's mirror the display. Yeah. So this is actually the generated code. We don't need this. This is the generated code before Ivy. And as you can see, maybe it's look like terrifying and something really hard to read, but we can find our div here and span. Let's close this. We can find the div, span, and also the ngif binding over here. And if we look at the folder structure, we see that we actually got inside the app for each and every component, don't only have the JS file, also have an ng factory file, and that's what we just witnessed. And if we look on Ivy, so now the factories are part of the component. They are actually inside, they are static function inside the component, and it's much cleaner, no? Even easier to read. So let's go back here. So as we said, few important things to notice when comparing Ivy before and after. The first one, we don't have factory files anymore. Now the decorators convert into static functions. As we saw, the component went to be ng component def. The second one, the set of instructions changed, so it can be tree shakeable, and it's much more smaller. In Ivy, we don't need the array with all the nulls and things. Every time I'm talking about tree shaking in Angular, I'm getting at least two guys catching me after the talk, asking me why they need tree shaking. They're not writing code they're not using. And the reason for that, this is actually a key factor to understand, because tree shaking is mostly effective for third-party libraries we are using, and not only for our code. So we have a smaller bundle, but Ivy is not only about bundle size. Let's take a look again on the transpiled code on the ngif section, which marked here. For some reason, my app component is associated with view container ref and template ref. And if you wonder where those two came from, they're actually dependencies of the ngif implementation. In Ivy, that's become much more simpler. Every component now references child components and directives through much more cleaner public API. And the meaning for that is, let's say if we change the ngif implementation, we don't have to recompile everything. We just need to recompile the ngif. So with that, we achieve two major things. First one is faster compilation, and the second one, a much more easier way to ship libraries to NPM. Now, Ivy is also providing a much easier debug API. Let's go for another quick demo. So I'll create an input with an input event and bind it to a not existing function. I don't have this surge on my app component class. So before Ivy, templates error was a nightmare and not really informative, but now in Ivy, we're getting the actual component, and as you can see, the problem is inside app component template in the input on the input listener. So you're getting much more informative error message. So we earned another goal with Ivy, better template debugging. Next one, dynamic loading. Demo will be the best way to make this point. So we're going to use this app, okay? And this app has two modules, app module and a feature module. The feature module will load lazily with the router and will present a feature component, okay? By default. That's it, I think. Yeah. Yeah, when clicking on the button, let's see the app. Now you see it. Great. Now, when I'm clicking on the button, I'm getting the feature walk, the feature component. Now, welcome to 2019. Now, the Angular router is supporting ES6 dynamic import functions. So I'm going to change the load children to the new syntax. Wow. I don't need this. So I'm going to import here the feature module, and I'm getting a promise here with the feature module. And here I just want to return the feature module, okay? And wait a second. It still works. No. Now, wait, this is not the important part. Now, given that, why won't we try the same exact thing to load the component directly without the router? So I'm going to my app component HTML file, and I'm going to change the router link here to a click event, which going to load feature. Let's implement this. So I'm going to use again the import function, and now I'm going to navigate directly to the component. Now, here, as we know, we're getting feature component, right? And for now, let's just return it. If we check again, right, and we check the network on JavaScript, let's clean everything. And now when I'm clicking, I'm getting some file, common.js, which is actually my feature component. But something weird just happened now, no? I just loaded a component without declaring it in any module, right? Weird. Well, the immediate question I have in mind is, do we really still need to declare components inside modules? And we will answer that soon, but first let's try to render the component on the view. So instead of just returning it, let's use a function by Angular called theta render function, render component. And I'm going to just use the feature component, right? Now I also need to declare the host, so I have two options here. The first one is just use the feature component selector. So I can go to my app component HTML, and over here I can use the app feature. And if I'm going to click here, sorry, what's happened? Yeah. So we got the feature component. The second option, actually, we don't have to use the app feature selector. We actually can use any selector, even selector that we don't have. So let's create just my container, and let's take it here. Theta render component is also a config. We can just send the host. And now, if we check it again, it still works. So that's all the whole idea behind incremental DOM, right? Since we since we don't tie it to ng factories anymore, so we can actually create component dynamically without the router, or without declaring them inside modules, right? But no, in the end. But not everything is green, and to demonstrate that, I'm going to create something even more interesting. So let's go to the app module, and I'm going to declare here an injection token, which is going to be the app name. It's going to be an injection token of type string. Let's say just, export const. And it's going to be a new injection token, type string. And let's say it's going to be the app name. Now I also want to provide it. So inside the app module, I'm going to provide the app name and use value IV. Now I'm going to inject the injection token I've just created inside the feature component we have. So we have this @inject, and we're passing the app name, public app name of type string. Great. Now I want to change the feature work into hello from app name. It's going to work or not? Hopefully. The answer is no. And the problem is that we don't have an injector. We've created a dynamic component, and components alone don't have injectors. At least they don't have the same injectors as their modules. Okay, so you're not getting the module injector. So there are also downsides for not creating component inside modules, but actually we can fix it. We can use, so the render component has another config that we can use called the injector, okay? That we actually can pass an injector by using the constructor. So I'm going to get the injector of type injector. Yeah, and here it's going to be this injector. Let's see. Now it works. Great. Let's go back to the slides. Yeah. So we have a better dynamic loading, and that's led me to our last topic for today. Well, last thing for today, AngularUP. First, what is it, AngularUP? Higher order component is actually a function which getting a component and return a component, but also affecting the component in between. And until now, we couldn't really do it, but now it's with Ivy it's possible. First, I have to say that my solution for AOC is pretty much experimental, since I'm going to use a lot of private functions from Angular. But the general idea here is what's important, just to make the statement that Angular with Ivy is dynamic enough to support features like AOC. And let's go to the demo again. So I'm going to create here a function which I'm going to call the AOC. This function is going to return me a component type. First, I want to save the original factory. So it's going to come from the component type, from the ng component, ng component def.factory. Now, I want to override this to get the args, and there I actually can create a component with the original factory using the args. Now let's return here the component and return also the component type. And in between, for now, I just want to console log it. Okay, so let's console log the CMP. Now, I want to use this function. How can I use it? Decorator, metaprogramming. So I'm just going to add it on top of my app component, AngularUP. And if we check, we're actually getting the app component instance with the injector and everything that's related to the app component. Now, let's combine the idea of dynamic loading and AngularUP to create something more interesting. So instead of just console logger, let's say that we're getting a config here, which getting a path to a component of type string. We're also passing the component name and the host, let's say. Great. Now, I want to use the import function again. So I'm going to get the config.path, right? Here I know that I'm getting a promise, so I want to take the result. And again, use the theta render component function to take the res config dot component, right? Now we also want to set the host. So the host will be from the config host. And now the injector, I don't have an injector. And I also don't have the Angular DI to get an injector. So you remember the ngc command we saw earlier? I used it to check how Angular is doing it. And this is actually my component rendered with Angular, with the ngc command. I saw that Angular taking the injector with theta directive inject. So let's try it. Let's see if it works. So I'm going to declare the injector, const injector, which is going to use the theta directive inject. And now I'm seeing that we can pass a token or just the injection token. Let's use the injection token of the injector. And we have an injector. Let's see. Last thing we forgot. We need to set the AngularUP properties. So the path going to be the path to the component. Let's take it from here. The component is going to be the feature component. Master of copy and paste. And host is going to be the my container. I've got the hello from Ivy. It's dynamic loaded by AngularUP, by our other component. Thank you, Shai. I love you too. I told you. Quick summary of what we just learned. So, Ivy, the third generation of Angular compiler, is really here. It has backward compatible, and by using it, you can get smaller bundles, easier to debug API, faster compilation, and dynamic loading and module and components. The future of Angular with Ivy looks really shining, and everything is dynamic, and we can get exciting features like AngularUP. Ivy also sets the ground, as Rob said earlier in the morning. Ivy also sets the ground for Angular elements to become much more popular in Angular application. I really admire you to give it a try. I'll post all the slides and all the material on Twitter, and you're more than welcome to check my latest blog about Ivy. Ivy is coming. And special thanks to Itai Oded for helping me with this talk. Thank you.